Okay, so our question here, what is the derivative of sine, but the argument of sine is x multiplied by 2? It's really just asking us to do this. Sine times 2, or sine of 2 times x. Okay, so the first thing that we're going to need to recall before we handle this is the chain rule. If you forget the chain rule, you're going to be in trouble. The chain rule is that when you have a function, like in this case, or we have a composition of functions and we're taking the derivative, in this case, like we have sine x, or we have 2x that is passed to sine x. So we have a function result as the input to the next function, sine x. The result of 2x becomes the input of sine x. Whenever we see something like that, we're going to need the chain rule. So the chain rule just means that we're going to take the derivative normally, but we also need to multiply that whole term with the derivative of what's inside, also known as the internal derivative. So the internal derivative in this case is d by dx, which means derivative. Sometimes you'll see like, like originally you have function and then function prime, but d by dx also means derivative of 2x. That's just equal to 2 because, with our rule, we subtract the power by 1. Here's x to the power of 1. Subtract it down to like x to the power of 0. That becomes 1. You multiply the whole thing by 1. It remains 2. So the result of this is 2. That's the internal derivative. So we need to do that is equal to, well, what's the derivative of sine? The derivative of sine is cos, positive cos. So let's just put that in as a positive cos. When you're doing the chain rule, like your external derivative, you keep the inside the same. So 2x stays the same, but you multiply with the internal derivative, which in this case is 2. Comes from there. So let's rearrange this to make this a little bit more beautiful. Here is just to be formal, but we can remove that now, and we can just move the 2 into the front. So we have 2 times cos 2x. That is the derivative of sine 2x. And this is our final answer. The only place that I feel like is a likely place of possible errors is perhaps forgetting to multiply the internal derivative. So make sure that you're really sharp and comfortable with the chain rule and that you will never forget to multiply the internal derivative, because if you do, your final answer will be wrong, and that's certainly something we do not want. Cool. So the solution that we see on OneNote is definitely the solution that we just calculated. So we can verify that the above solution is correct. Super. That's very nice and handy.